All right, let's get right into it. Today, we're taking a look at how artificial intelligence is fundamentally changing software test automation. For any technology leader, getting a handle on this shift isn't just a good idea anymore. It's absolutely critical. We're going to cover the core technologies, what they look like in the real world, and the big strategic questions you should probably be asking your teams right now.
So let's start with something I'm sure is all too familiar for many of us, what we call the testing dilemma. We've all poured resources into test automation, right? We're all chasing that dream of fast, reliable feedback. But more often than not, that dream gets stuck in the mud, bogged down by some really persistent and expensive problems.
And that leads to the central question, doesn't it? In this age of agile and continuous delivery, why does our test automation so often feel, well, brittle and slow and incredibly expensive? This isn't just some engineering headache. It's a real bottleneck that directly impacts how fast we can innovate.
And these are the big four challenges that pop up again and again. First, just the sheer cost of writing tests, and then, of course, constantly maintaining them. Second, and this is a big one, those notorious flaky tests that fail for no clear reason, which just destroys trust in the whole pipeline. Third, the real struggle to get good test coverage, especially when you're dealing with complex or older legacy systems. And finally, feedback loops that are just too slow. They can't keep up with how fast our development teams are moving. Okay, so if that's the problem space, what's the solution look like? Well, the answer is emerging from a new AI-powered toolkit, and it really breaks down into three foundational pieces. Let's walk through them. First up, you have what we call AI agents. The best way to think of these is as autonomous workers for your testing process. They can actually generate new tests, they can explore an application to find weird behaviors, and they can even try to repair broken tests all by themselves. This is huge because it takes all those repetitive, time-sucking tasks off the plates of your engineers, letting them focus on bigger picture strategy. Next, we have something called MCP Servers, which stands for Model Context Protocol. Now, just think of an MCP server as the central nervous system for your entire testing world. It's the backbone that lets all the different AI agents and tools share critical information. So, for example, if a test fails, the MCP server can feed an agent the exact code changes, the system logs, and performance metrics from that specific build. This allows the agent to make a much smarter decision about how to fix the problem. And the third piece of the toolkit is AI-Augmented Tools. Now, the goal here isn't to replace your engineers, it's to empower them. These are tools that embed AI directly into the frameworks that your teams already know and use. They provide incredible features like self-healing UI locators, the ability to write tests using plain English, and smart prioritization of which tests are most important to run first. So what does this look like when you put it all together? Well, the workflow typically starts with an AI analyzing your source code and your application's UI. From that analysis, the AI agents start generating or suggesting tests, and they're constantly pulling context from that MCP server to do their work intelligently. The tests are then run, and the results feed back into the system, making it smarter over time. But look at that last step, because it's the most important one: human oversight. A person is always in the loop for review and for strategic guidance. This isn't just automation, it's collaboration. Okay, that's enough of the theory. Let's talk about what this actually looks like in the wild. We can look at a few well-known tools that are already putting these concepts to work and delivering some really measurable results. This table gives you a pretty good snapshot. Take Testim, for example. It uses machine learning to create these self-healing locators. So instead of a test breaking every time a developer changes a tiny bit of CSS, the AI understands the element based on multiple attributes, making the test way more resilient. Then you have GitHub Copilot, which uses large language models to help developers quickly build out unit tests, which really helps boost coverage. And we're even seeing foundational tools like Playwright starting to integrate with this MCP concept, basically positioning themselves to be the go-to execution layer for this new wave of AI agents. And look, these aren't just fuzzy benefits. We're talking about hard data. For instance, customers of Testim have reported seeing over a 40% reduction in flaky test reruns. Just think about what that really means for a minute. It means cleaner builds, way less wasted engineering time chasing ghosts, and a whole lot more trust in your CI/CD pipeline. And it's a similar story with developer productivity. A recent study found that development workflows that are assisted by GitHub Copilot can lead to as much as a 30% increase in unit test coverage. This directly tackles one of the oldest challenges in software quality. How do you get comprehensive test coverage without completely slowing down your developers? But of course, no new technology is a magic wand.
And for us to have a credible conversation about this, we have to be upfront and acknowledge the very real challenges and risks that come with intelligent automation. There are some serious questions we have to tackle head on.
So the first and maybe the biggest question is all about trust. When an AI generates a test for you, how do you actually know it's correct? How do we make sure it's validating the right business logic and not just, running without throwing an error?
This gets us to what's called the correctness challenge. The issue is that AI-generated tests can often have what are called shallow assertions. They might check that the code runs and doesn't crash, but they might completely miss whether it produces the correct business outcome. Without a deep semantic understanding of what your application is supposed to do, you can end up in a situation where you're maximizing your code coverage numbers, but you're not actually improving the quality of your product.
The second critical question we have to ask is about security and governance. As we start to automatically generate code that runs inside our systems, we have to ask, is this code secure? And is it compliant with all of our licensing and data privacy policies? And the risks here are very real. A 2023 study by Fu and his colleagues actually found that AI-generated code can introduce common security vulnerabilities, not to mention the risk of accidentally exposing sensitive data or violating code licenses. This is exactly why having a human in the loop for review, along with strong security guardrails and clear audit trails, is absolutely non-negotiable.
So when you weigh all the incredible potential against these serious risks, where is this all headed? Well, the most promising vision isn't about fully replacing humans, but about building a hybrid, self-improving ecosystem for testing.
The consensus from the research is really clear on this. The future is hybrid. It's not about finding one single perfect AI technique that solves everything. Instead, it's about cleverly combining the unique strengths of several different approaches to create a system that's far more robust and intelligent than any one piece could be on its own. And this is what that hybrid model really looks like in practice. You use large language models because they're great at understanding semantics and generating test ideas quickly. But then you combine that with more rigorous techniques like symbolic execution, which can mathematically prove things about your code to guarantee logical soundness. And then you layer reinforcement learning on top, which allows the whole system to adapt and get smarter based on the feedback it gets. See how each component is there to cover for the weaknesses of the others? This quote from the source material really just nails the end goal. It's all about creating an ecosystem that isn't just automated, but is resilient, adaptive, and ultimately trustworthy. The real holy grail here is a system that learns and gets better all on its own, one that becomes truly self-improving over time. Which, of course, leaves us with one final and really important strategic question. As AI takes over more and more of the mechanical work of generating test code, what is the new role for our human engineers? The answer really points to a big shift in focus, away from writing boilerplate code and toward exercising the creativity, the critical thinking, and the strategic oversight that ensures our testing is not just automated, but that it's truly intelligent.